Hi everyone, hope everyone doing great today. Whenever you're watching this video, so I've just decided to make some video on vectors in P4. It looks like a big topic, but actually something which is very brief. So I go through the main aspects of the topic with explanations and and examples. All right. This is the list of the things that you're going to go through. The most important thing. I know it looks clear in the textbook when you look through all the content over there. So this is the summary of everything that you're supposed to know. Okay, now the vectors in 2D. These are the vectors we already seen from year 11. Now, what are vectors? Now, when you consider a Cartesian plane, this is x and this is y, and look at maybe a point A. If this point A is a point, say, 3, 4. This point A, 3, 4 can be transformed into the vector. I can define the vector here, the vector from the center O, and then I have a vector here as a vector OA, like that. That's a vector OA with that arrow. That's called a vector OA. It means that the vector running from O to A, and I write it as in column vector. This is what we call a column vector. In a column vector, that's what I call a column vector in matrix form. That's a column vector. O to A is 3 to 4. What it means here is that in order to move from O to A, I'm going to move 3 units over here, and then 4 units up. So I have a vector O to A. Now, vector O to A, it just means the position. It just means the position of A relative to O. You have the origin. You have to O, the origin, and that vector OA is called the position vector. It's called the position vector. The position vector is always relative to the what? Relative to the origin. Now that's vector A, the vector OA. As you have seen before, that you always have an arrow to show the vector where it's starting from O to A. I can even have another vector. For example, I can have another vector. Say this is vector B. This is the point B over here. Maybe this is a point 3. Why cannot be 3? That's be so close. I'll just erase that. Just use another point here. Okay, I can have a point, say maybe that is 3, so this maybe it is 5, and then you go up only 2, and then that is it. Okay, now that's a vector. That's the point B. From the point B, we can define the vector that starts from O to point B. That's a vector over there, and then that's a vector OB. In this case, our OB will be a vector which is 5, 5, 2. It means that you move 5 across and then you move 2 up. Now we can even define another vector, which is going to be a vector from A to B. I can have that vector over here, from A to B. That's not a good line. I don't like it. From A to B. Okay. A vector from A to B. You can have it over here. Okay. Okay, a vector from A to B. You can have a vector over here. Okay, A to B over there. Okay, now if I want to get a vector A to B, you can see we are looking for the movement from A to B, and the vectors are always movement. The vectors are always movement. Look at the vectors at movement. So if I want to move from A to B, I'm going to move from A to O, and then plus O to B, O to B. Now you can see here the vector O, A to O, you are moving against the vector which is O to B, so it becomes negative OA plus a vector OB. That means if I'm looking for the vector AB, it's going to be a vector negative OA, where A is 3, 4, and then this plus a vector OB, which is a vector 5, 2. So my vector AB is equal to minus 3 and 5, which is 2, and then minus 4 and that, which is minus what? Minus 2. Now you can see I've done some things over here. One, I have added vectors. You can see over here I've added vectors. That means we can add vectors. I have added vectors. That means we can add vectors. If we can add vectors, it means that we can also subtract vectors. So that's what I've done over here. We can add or we can subtract vectors. Now the vector I've got here, which is 2, negative 2, define this vector A to B. It's defining the position of B relative to A. It's like, how do I move from B to A? It's defining this vector over here. I can draw it over here. It's defining this vector over here. If you have a grid and you want to count it, you can see the vector you're talking about is the vector over here. So this vector over here, like that, and then like that. It's defining that vector over there. That's the vector it's defining. All right, it's saying that, oh, you're going to go negative 2 down, and then you're going to go 2 across. That's the vector from A to what? A to B, but you can get it using this addition here. This addition over here is what we call the triangle law of vector addition. The triangle law of vector addition. Okay, or vector addition. Now, you have seen this. This is not new, unless some people have not done vectors in year 11, but you have seen this. This is not new. But one thing I want to highlight over here, I want to highlight what you call the position vector. This one over here, the position vector. That if I have vectors A or A or B, those are called the position vectors. Then the other thing I want to highlight over here is this formula over here. You can see for this formula here, if you rearrange it properly, you see that AB is equal to, when you start with the positive 1, minus OA. Now, this formula will always be true as long as you're dealing with position vectors. That means at any one point, if they ask me to find a vector, say PQ, I can say PQ is equal to OQ minus OA, minus OP, without any problem. It's always true. All right, so this is coming from the triangular law of vector addition. And then the position vector AB is just the position of B relative to what? Relative to A. So position vector, addition of vectors, we shall see more of this. And this one over here, the law of addition. These are the things I want to highlight in this section here. Here is all in 2D. Now we want to extend this same concept over here into 3D dimension. Now, how will it work in 3D dimension? I am going to erase this as that 3 dimension. Now, this one has 3 coordinates. So if I want to define a point, like say a point over here, on the top over here, you can see in order for me to define this point here, I need 3 dimension. I need to know the movement in the X and the movement in the Y, then the movement in the what? In the Z. So I'm not going to move. I'm looking for another color here. I'm going to move from my center over here, 0, 0. I can move the point. So you move, say, in the X over there, and you move, say, in the Y, and then you move to in the Z dimension. Then you come up with your vector over here. That's a vector from O to A. Now, the coordinates of A is going to be the X, the Y, and the Z. So, for example, if I have my A as, say, maybe it is 2, 3, and 5, that means that I'm going to move 2 over here, 3 over here, and 5 over here. It is a 3D dimension. You get a vector O to A, which is a vector 2, 3, 5 as a column vector. I can define another vector as well. So if I have another vector on this column over here, say that's a vector B, that's a point B, and that point maybe it is in the XZ plane, that means the Y is 0. So I'm going to give it as 2, and then 2, and then the Y is 0, the Y is 0, and then the Z maybe it is 3. Yeah, something like that. So there's a mistake here. I'm supposed to write it as X is 0, then Y is defined, and then Z is defined like that. Okay, so even if I have another point over here, B, still I can come up with a vector OB. It's the same way. Vector OB will be equal to 2, 0, 3. So what I'm saying here, we are just extending the concept of the vector in 2 dimension into 3 dimension. It's exactly the same kind of concept and the same kind of characteristic I'm going to use. Now, if I want to get the vector A to what? A to B, so I can get a vector A to B. Let me get it over here. If I want to get the vector A to B, running from here to there, so I can use that. Where's my color? I don't know whether big guys will be able to see it, from running over there to there, from A to what? From A to B. Still, I can come out a vector A to B, but I don't have to overthink about it. All I need to do, I need to remember from the vector law, from the triangular law of addition, that this AB is equal to OB minus what? Minus OA. Then I just use that, and I have OB as 2, 0, 3 minus OA, which is 2, 3, 5. So when I subtract that vector, so I have 0 minus 3, and then I have minus what? Minus 2. That is the vector. Now, one other thing that we can also think about here, so it's exactly the same kind of operation, but now we have 3D dimension. Now, the other thing you have to think about, opposite vectors. Now, if this is vector AB, if I'm looking for vector BA, it's just going to be the same vector, but opposites be 0, 3, and 2. So you should know about that, opposite vectors. All right, we move on to the next thing. The next thing now is the magnitude of the vector. The magnitude of the vector is the size of the vector. The magnitude of the vector is the size of the vector. So if I have the point I started with, point A, which is 2, 3, and you're looking for the size or the distance of A from the origin, the distance of A from the origin, my vector OA is equal to 2, 3. That means OA modulus sign. This is a modulus sign, but I don't want to create a modulus sign because the modulus doesn't bring out the meaning of it. So I want to create the magnitude. I want to just read it as the magnitude of A, or the size of A, the length of A. That's what the modulus sign is doing there. All right. Now the modulus of A, or the size of A, is going to be equal to, guys, think about it as Pythagorean. So this will move how many units over here? This is a vector with 2 units across and 3 units up. This is a Pythagorean here. So it is 2 squared plus what? Plus 3 squared. That's the magnitude of a vector. And then you have your OA, just square root of what? Quick math here, square root of 13. That's your modulus. Now, it's the same kind of thing we are going to see if we extend this to a 3D. If we say that vector B is a vector which is 1, 2, 5. So if we're looking for the size of B, that's the modulus, or the magnitude of B is going to be equal to just 1 squared plus 2 squared plus 5 squared, which is equal to, so the modulus of B is just root of what? Root of 30. That's the modulus of B, so root of 30 units. All right, so the size or the magnitude, this is very important. It's very, very important. So you guys need to remember it. So the size or the magnitude, just that means the vector O to A, it has square root 3, square root 13 units. The vector B, it has root 30 units. So sometimes the vector I've seen, they were all given the form of OA, the one you have talked about, but now you can see I can just give a vector just in the form just vector B is equal to that, or vector C is equal to that, and then you can do any operation you want with these vectors. All right, let's go to the next thing. That's about the size of the vector. Let us go to the next thing here, the unit vector. Now, the unit vector and then the iron notation. The unit vector, from the word unit means one unit. So 1 unit. That is a vector of size 1. Right, vector of size 1. It has only one unit. Now, how does the unity vector and then the ing notation comes in over here? Now, when we consider vector, when you consider our grid here, and then we have our y, we have our x, and then have our z over here. Now, if I consider a point over here, say point A over here, and this A is a distance of exactly 1 unit from the origin. Is that the distance of exact 1 unit from the origin? That means this is a vector of 1 unit. That's a vector of 1 unit, and is at a point which is 1 over here on that axis. And what will be the coordinate of this point over here? I'm calling this point, say, A. What will be the coordinates of that point A? That point A will be a point whereby it has 1 on the x. On the y, it has 0. It means that even on the z axis, it has what? It has 0. If you defined it in the 2 dimension, it only be 1 what? 1, 0. But you see over here that this vector is a vector parallel to the x-axis. This is a vector parallel to the x-axis. Vector parallel to the x-axis. Now, I didn't talk about parallel vectors, but I'll go into details about parallel vectors. But at least everyone knows that this vector from O to A is a vector parallel to the x-axis. Now, this vector parallel to the x-axis A is a vector, so 1, 0, 0. Or you can see in this dimension over here 1, 0, 1, 0. Now that means there's also another unit over here. There's also another vector over here at this point here, which is parallel to the y-axis. There's another unit of 1. There's another vector of one side. There's also another vector of what? Of one side over there, parallel to the z-axis. So these vectors over here, the vector parallel to the x-axis, this unity vector parallel to the x-axis is what you call the I. And the vector, a unity vector parallel to the y-axis is what you call the j. We give them special names called the j, and this one over here we call it what? The k. That means if I have a vector, a point over here, if I'm going to write this in 2 dimension, I'm going to write this point in 2 dimension. The one I started with, OA, in 2 dimension. If I have a vector OA in 2 dimension as a point which is 2, 3, it means that this point here, we have moved how many unity vectors across? You have moved 2 unity vectors across. 2 unity vectors across. And you have moved 3 unity vectors up. 3 unity vectors up. That means you have moved 2 of your i's plus 3 of your j's. So that's why that line is also called 2i plus what? 3j. Now, if I write this point in 2 dimension, because in 3 dimension, because it has only the z, I mean, it has the 0 in the z dimension, it will be 2i plus 3j, still the same kind of what? Of vector, because it is 0 in the z dimension. If I have any other point, say my point OB is a point, say it is 4, 6, -5, it means that this in the unity vector form, it is 4i plus 6j minus 5 what? Minus 5k. Only that. All what it means that you have 4 units along the x-axis, 6 units along the y-axis, and -5 units along the k-axis or along the z-axis. That's what it means. That's the I and j notation. We have our vector. I use good numbers over here. I use 2D. I come back to that. I'll use the 2D over here. Okay, I use this vector over here. Suppose you have a vector here. This point here is a point, say 3, 3, 3, 4. I use 3, 4. I don't want to get bad answers. I want to get good answers. I use 3, 4. So if I use 3, 4, so I have a vector O to A. A vector O to A. So OA is a vector which is, say, 3i plus what? Plus 4j. Now, what's the size of OA? What's the modulus? What's the magnitude of OA? OA is just square root of 3 squared plus what? plus 4 squared. So the modulus or the size of OA is 5 units. Now that means that OA has a size of 5. This vector here, A has a size of what? Has a size of 5. Vector OA has a size of 5. All right, now what I want to find here, I want to find a unity vector. From here, I want to find a unity vector. But parallel to OA. We want to find a unity vector parallel to OA. How do you find that? That's a question. Right, but let us first understand what's a unity vector parallel to OA. All we are saying here, we are saying that what we need a vector that should be unit. That means should be only one size, but that vector should also be parallel to what? To OA. Now I think I need to first take some time, and then I'll explain to you parallel vectors before I continue with the unity vector. Now, if two vectors are parallel to each other, the vector, they should be multiples of each other or fractions of each other. So if A is parallel to B, it means that A is a fraction or a multiple of B. That means if I have a vector A as say 1, 2, 4, I can get so many vectors that are parallel to this vector over here, as long as they are multiples or they are fraction of A. That means I can multiply this by 2, and then I have say 2, 4, 8. That means I can multiply by -3, then I have -3, -6, -12. I can have by a half, so that I have another vector which is the half, and then 1, and then 2. All these vectors are parallel to what? Are parallel to A. But you can see they can have different sizes. So if this is A, the one I multiply by 2, it will be like 2 times. The multiply by -3, it will be even bigger, but in a negative direction. The one I multiply by a half will be something like that. So, but they're all parallel but different directions. So if they ever ask me to show that two vectors are parallel, all I need to prove that one is a multiple of the other, or is a factor of the other, or is a fraction of the other. Just that. Then I know they are parallel. So that means over here we need a vector that has a size of 1. Guys, I will erase this. The video is running. So to OA, it should be a multiple of OA, but should have a size of 1 unit. Now that means we come on this vector and get out only 1 unit. But we know this vector is 5 units. That means out of the 5 units, we are taking only 1 unit. So we are dividing this vector by 5 of 1/5 of what? Of OA. So the unity vector parallel to OA is 1/5 of OA, which is 3i plus 4j. So that will be the unity vector. Or you can write it as 1/5 of what? Of 3 and 4. In general, the unity vector is always going to be A over the modulus of what? Of A. That's the unity vector parallel to the vector A over the modulus of A. It's like you just have your vector and divide it by the size of the vector so that you can get a vector of only 1 unit. So you're taking 1 unit out of the same concept. If I have this vector in 3 dimensions, the same concept is extended. If my vector B is 3i plus 5j minus 7k, the unity vector parallel to B. You guys, you can pause the video and try to get the answer for this. Find the unity vector parallel to B. You can pause the video and find the answer. Okay, so we say that all we need to get first, we need to get the modulus of B, so the size of B. How big is B? Then you get the modulus of B. So you have 3 squared plus 5 squared plus 7 squared. Do I have to put a negative over there? It doesn't really matter if you put a negative or not. Okay, so now you can press your calculator. So you have a root of root of 83. So my unit vector prior to that will be 1 over root of 83 into 3i plus 5. This is not 4, this is 5. 3i plus 5. Okay, 3i plus 5j minus 7 what? 7k. That's your unit vector. Pilot what? Pilot to B. All right, the 4 operations about vectors. Now we can add vectors. Where's my pen? Where's my pen here? Where's the pen? We're not writing. Okay. We can add, we can subtract. Can we divide vectors? I don't think so. We can't divide vectors, but we can multiply vectors. When you're multiplying vectors, we multiply by a scalar, by a constant. We cannot multiply a vector times what? Times a vector. I'll explain this by these examples over here. So if I have a vector, if I have P is a vector that, Q is that, and then R is that, find A, P plus Q, so you just have 502. Guys, you can pause the video, do the question, and then see if the answers, if you're doing exactly the same what I'm trying to do over here. So then plus 2, 1, negative 3. We have already seen the addition is exactly the same thing. Nothing changes. Okay, this is grade 1 work. Okay, now B is equal to Q minus R, 2, 1, negative 3, minus your R, which is 7, minus 4, 2, equals 2. We just have to subtract. So minus 5, and then 5, and then this is going to be 2 minus 5. Oh, this is good. Okay, so that's the same thing. This is addition and subtraction is exactly the same. Now over here we have the multiplication by a constant. So the multiplication by a constant. So D is 3 times P. So get 3 times your P. Your P is 502, and then subtract the R, which is 7, negative 4, 2. So what you have? You multiply. Just multiply all the terms. You multiply all of them by what? By 3. So you just have 15, 0, and 6, and then subtract 7 minus 4 and 2. That's how it works. So that I have 15 minus 7, which is equal to 8, and then you have 4, and then you have this is 6 minus 2, which is 4, like that. Now this is how vector addition and subtraction works, and the multiplication by a constant. We multiply by a constant. Now so if I multiply a constant, I can say, oh, this is R. Oh, I can multiply R by 3 or by 4. Anything can do. So 4R means get 4 multiplied by R. That's what it means. 4 multiplied by R. So this is 28, and this is minus 16, and this is 8. Now, the rest or the things I've talked about before this, these are the things that we expect you guys to know. Apart from the 3D, maybe 3D and then the I and J. But still the I and J, you guys have already seen it in mechanics before even seeing it in the pure section. So this is where the things that are totally new comes in over here. That's the vector equation of a line. Now this is the easiest line I've ever seen, the vector equation of the line. Now, if I have a line passes through 2 points, say point A is 1, 3, say negative 2, and point B is 5, 6, and maybe 0. And what you want to do, we call this one here line 1, and you want to find the equation of this line. The line passes through the point A and B. You want to find the equation of this line in vector form. All right, now in vector form, the equation of the line is just written as A plus lambda B, where A is a point on the line that is known, and B is the direction of the line. Line in the vector format is you just have any point on the line and then a vector that's parallel to the line. This is the direction of the line is going to be the vector parallel to the line. The vector parallel to the line, that's the direction of the vector parallel to the line. Now over here, the direction of the vector, the line runs from A to B. That means the direction of the vector is that AB will be the direction of the vector. AB is OB minus what? Minus OA. OB minus OA. Now, the question can be, you should be asking yourself now is that, how did you know it's running from A to B? I don't know if it's running from A to B. All I'm saying over here, it's running from A to B. That should be correct. Or even if I say it's running from B to A, that will also be what? It will also be correct. Because all they've told us that the line connects A and B. Or the line runs through A and B. If they say the line goes from the direction of the line from A to B, then I have to care about the direction of my directional vector. But in this case, no, we're just getting the general equation. So you have your B 5, 6, 0, and you have your A 1, 3, negative 2. So the direction of your line is 5 minus 1, which is 4, 3 minus 1, which is 3, and this which is 2. That's the direction of your line. That means the vector equation of the line L1 is A, the position, and the position of a point, and lambda. Lambda is any parameter. Lambda can take on any value. Lambda is any parameter, can take on any value. All right, I can even change the lambda there and put there t. I can put there s. I can put there anything I want to put over there. For this lambda value, it's any parameter, I can take on any value. Now, someone going to ask me, what if I used this? Yeah, I used, instead of using 1, 3, negative 2, I use that one over here. That would be correct as well. So your equation can as well look as 5, 6, 0, plus lambda or t 4, 3, 2. Another one can say, what if I used BA, not AB? Still your line will be correct, and my line, my same line here is equal maybe 1, 3, negative 2, and then this is equal to plus, say, mu of, say, I'm going to use BA, so BA will be minus 4, minus 3, 2, like that, minus 2. That's also good. What if I use the vector that is parallel to this vector B? That will also be correct. That means there could be multiple answers for this equation. All right. Now, how does the lambda change, or how does the lambda determine what you're doing over here? Now, as we said, the value of lambda keeps, so you can, for any value of lambda, you get a point. For example, if lambda is equal to 0, I'll get this point over here, A. If lambda is equal to 1, I get another point moving along. If lambda is equal to 2, I get another point. I just substitute, I get another point. So for any value of lambda, you come up with your points over here. This L over here is basically stand for x, for xy what? For xyz, stand for xyz, like that. That's the vector equation of the line. Let us see some examples over here. So the first one, you can pause the video, try out the questions and see if you can get the answers correct. All right. The first one says, find the vector equation of the line which passes through a point with position this. So you see, they have given the point and which is parallel to that. So use lambda as your parameter. That's good. So the line, I can just call my line R equals to the point, which is 2i plus 3j plus k into lambda, and the direction is I plus j plus 2k. Or I can give it in column vector form. R equals to the point 2, 3, 1, and lambda 1, 1, 2, like that.